Hello everyone, I welcome you to this learning activity. In this activity, we will collect an image collection or think of it as a bundle of images for a project. The aim is to search the Earth Engine database for satellite imagery and filter the image collection to meet a project requirements. We will explore Sentinel-2, another satellite data source often used in workplaces. Let's now head over to the code editor to unpack. Once you are in Google Earth Engine, we're going to create a new script file. And then you give it a name. So I'm going to call this activity 5 and filter image collection. All right. So this is my file name. You can choose a different name for your one and then just click OK. So once you are here, I'm going to click on this new file and then I'm going to start the project. So what we're going to do is that we are going to use Sentinel-2, right? So when you type in Sentinel-2, you see a bunch of image or data associated with Sentinel-2, and we are going to use the surface reflectance, which is the level 2A. Okay, that is what we're going to use. But before we get into that, I want us to explore the level 1C. So the level 1C is the one that has not been corrected for atmospheric effect. So the way the satellite collect images, sometimes the gases in the atmosphere and then particles in the atmosphere can introduce error in the measurement. So for you to have a more accurate measurement, you need to correct for that. And so that has been corrected. So the level 2A is the best data to use. And that is what we're going to use. But I want us to explore the level 1C. So when you click on the level 1C and you go to bands, you see B1, and then there's a description around it, and then the pixel size for B1 is 60 meters, and then the wavelength, is been given as well. And then this is a scale factor, to transform the image or the pixel if you want to use it for analysis. And B2 is the blue light, and that is in 10 meter by 10 meter pixel. And then the wavelength is also given to you here. So this is very important in terms of understanding the bands available. We have the quality assessment bands also available here that we normally use to improve the quality of the analysis you make. And then you can explore the image properties, and when you are talking about how much of cloud cover is in the image, you're going to either use the cloudy pixel percentage, or sometimes you use the cloud coverage assessment, and it tells you the data type and then the description around that. So we're coming here because we'll be using some of this information to filter the image. Okay, so you can see with the data set availability, this data has been available since 27th of June 2025, and this data is provided by European Union through the European Space Agency Copernicus program. And so if you want to bring this whole collection, so this satellite is collecting data over the Earth, and so the data is global. So once you click import, this whole data set is going to be available in your code editor. And so this is where we are going to filter, because you don't need all of this data. You are not going to analyze the whole world. You want to analyze a particular study area. So what you need to do, you need to filter. This data has been available since 2015. Sometimes your time of interest might be, say, 2020, and not 2015. So you need to also filter the time, because you might not need all these data, and that is what we're going to do. It could also happen that you don't need all the spectral bands, and then you need to filter that as well. Okay, so we're going to filter this collection, and so you can see that it says that is what image collection. Okay, so this is an image collection. It is not an image, it's an image collection. What that means is that you have a bundle of images, like millions of images all stuck together. So that is why we call it image collection, and that is what we're going to explore. So I'm going to close this for now, and we go back into this one here, and then we are going to use this one, which is the level 2A. So again, if you read the description, you know what the difference is between the level 2A and then the level 1C. So the level 2A that are in Google Earth Engine is available from 2017, not 2015. It's available from 2017. All right. So this is the data that has been corrected for atmospheric noise. So this is the best data to use for any analysis. Okay. So when you scroll down, we're going to, like I said, you can easily import by clicking import into the script. That is an option, but I want us to take the other option where we're going to copy. You just copy the snippet here, the collection snippet. You just copy it and then close this tab and then stick it here. And then once you add it to your code editor, we're going to create a variable. So you just create a variable. So we declare the variable by giving it a name and also using var. So once you have created a variable, you're going to print the variable to the console. So we're going to print this variable, the name of the variable. You just copy the name of the variable here and you just stick it in here, and then we're going to print this variable. So let's see what happens. Once you click print, it's going to print to the console. And you can see it spits out error message. It's saying that the collection was aborted after accumulating over 5,000 elements. So what this tells you is that there are more than 5,000 images in this collection, and Google Earth Engine can display up to 5,000 elements at a time. More than 5,000 elements, the computer is going to show you an error message like this one here. So when you do this, it's just saying that you got a lot of images in the collection, and all of these things cannot be displayed. All right, so that is the learning here to do. So the next thing we're going to do is that we now have got the image collection, and now we want to use this data for a project. So the next thing you want to know is your project area. Where is your study area? So we need to know the study area, because like I said, you are not going to use all of this data. You want this data for a particular study area. So let's say Darwin is our study area. So when you go to Darwin, let's say this is Darwin and this is our study area. All right, okay. So what we're going to do is that we are going to use the tools here. This one is for panning, to pan. The hand button is for panning. This one is for dropping a point. So if I click here, I can drop a point here, right? So this is to say this is my location, all right? And this one is for drawing a line, and this one is for creating a polygon, and this is for a regular polygon, like a rectangle or a square, you use this. In this activity, we are going to create an irregular polygon to define our project area or study area. So we're going to use this one, okay? So to do that, I'm going here and I'm going to delete this one, the point I dropped here, and then I'm going to take this one here, and then I'll click, move, click, move, click. So this is my study area, right? Since you're going to do it by yourself, the size of your polygon might be different to my one. You can choose a different location, all right? So this is all for demonstration purposes. So assuming this is my study area, you can see that it creates a geometry and then it quickly includes it in the code editor. So what I'm going to do is that it gives it a default name geometry. I don't want that, so I'm going to give it the exact name, and I'm going to call it region of interest, ROI Darwin. Okay, so this is the name I've given to the polygon. You can change it to a name that you feel is more sensible to your project. So I said this is my project polygon, and I'm going to use that. So now the name is changed here, and it's also changed there. You can turn this one off. Once you turn it off, it's gone. You turn it back on and you can see it. So if you don't want to see that, you turn it off. Okay, so what we're going to do now is that we're going to use this polygon to tell the computer to give us data that came from this region of interest only. We don't want data from the whole world. We only want data, the Sentinel-2 data that was collected for this study area. So that is all what we're going to do. So the next thing we're going to do is that we want to filter this big data, okay? So we're going to filter the collection. So filter collection. And what we're going to do is that we're going to bring the object we created here, this variable here. So that is going to be Sentinel-2, and then we're going to filter that. So how do you filter? This is image collection. So to filter this, first of all, we want to filter by the polygon we've created, our region of interest or our study area. So you go to docs, and then you're going to look for this function, okay? You're going into this toolbox, image collection, this one here. So this one here. And then we are going to filter. So we're going to find a method to filter things. So like I said in the previous video, everything is in alphabetical order. So filter is going to be here. So this is it. We filter by bounds. So if you want to filter by this polygon or the region of interest, you're going to filter by bounds. So here I'm going to copy this here, filter by bounds. I'm going to copy it here. I'm going to copy this, filter by bounds, and then I'm going to apply it. So when you have a method, you always apply it to the object. So this is the object. I'm going to apply is dot, and then the method. So this is the method here, and then I'm filtering by what? My region of interest. So instead of this name here, I'm going to copy this name. I'm going to copy this name to replace the one here. All right. So this is me filtering by what? The geometry, and so now we are going to have this Sentinel-2 data for this study area only. Okay, the Sentinel-2 data for this study area only. But remember that this data has been available since 2017. Okay, so let's say that your project is to cover the period between 2022 and say 2023. So it means that you also need to filter by date. So we are going to filter not only by the study area, but we're also going to filter by what? date. So we are going to filter by the date. Okay, so what we can do here is that we copy the date. So see this method, filter by dates. So once you copy that, and then what I'm going to do is that this must be long. So I'm going to apply, then date. Okay, so I'm going to paste the method here, right? Okay, so what I'm going to do is I'm going to break this thing down. So this is the object, apply, and I filter by the region of interest, apply, and I'm filtering by dates. But I don't know what start date is and end is. So what I need to do is that I need to go to the description here and then just read about this. And then based on the information here, okay, I can specify, and even example has been given. If you scroll down a little bit, the start, it should be a date, which could be a string or a number, and that is inclusive. And then the end is the same thing, a string, but this is always optional. And then we're going to create that. Okay, so we're going to say this is our start date, 2022, first day of 2022, and then the end date is last day of 2023. So in this case, I'm going to put it. So this is not inclusive. So it means that you want data from first day of 2022 to 30th December 2023. Okay, that is the end date. So this one here, I will put comment to say filter by study area or project area. And then the next one here, we are filter by date. So the date for the project is what we are after here. So now this big data we got, which had more than 5,000 images, we have now limited it to the project area, and also we are limiting it to these dates, from 2022 to 2023. Okay, so let's say we are happy with this one. Now what we need to do is that we need to assign this to a variable. So declare it var, and we're going to keep the previous name. So we're just going to keep the name, we will leave it unchanged, and then we assign. All right, so this is new object, or sort of we've modified the object we created in line 2. We've modified it by fitting, by study area, and then by date. Okay, so now that we have that, what we can do is that we can print to the console and see whether that can get us around this error message we are seeing here. So what we're going to do is that I'm going to print, and then I'm going to paste the name of the object, and then let's run this. Well, when you see the console, you see that now something is printed. So this error was a previous error, but now something is printed here. And then when you explore the console, you can see that it says the data type is image collection, and then the collection ID has been given here. And then under the bands, which is list, you can see by the square bracket that is a list. You got features there. So we got a lot of images. How many images do you have here? We got 304 images that was collected between 2022 and 2023 in this study area. Okay, we had 304 images. So when you do it at home, you may have a different value to what you are seeing here, because your study area might be different to my one. So I expect that your results may not be the same as what you are seeing here, but that is okay. It is the steps that you have to get right. Okay, once you go through all of this is really many. So if you look at the first image, let's explore the first image. The image itself has got its own ID, and here when I move this a little bit back, you can see that the image was collected somewhere 4th of January 2022. Okay, you can click on the bands and you see all the spectral bands available here, including the quality assessment bands. Okay, so you can also go to properties, and you can see that this first image has 95, almost 96% cloud cover. So you can see that it is sort of useless because the whole location is covered by what? Cloud. So which means that it is not really good. So you have to say, well, we don't need this particular image because it is completely cloud covered. So you don't need it. So this is where we have to go and improve our script here by including what? By including the cloud coverage assessment. So we need to limit this to a good number, not something that will give us like 50% cloud cover image or 70%, and in this case about 96% cloud cover. So we need to also filter by cloud cover to be sure that we are getting high quality data. And this is what we're going to do next by taking our script here and then improving it. Okay, so we're going to keep the script here, and we are going to add another level of filter to this. So I'm going to include also filter by cloud cover percentage. So I'm going to go, and this is what I'm going to do. So we're going to filter, and then we go to EE filter. This thing is less than or equal to. This means less than or equal to. And you can see that the item we are after here is what? Cloud underscore coverage assessment. So that is what you need to include here. And then the 10 here, you see that it is the percentage. So we are saying to the computer that give us the images that has cloud cover not more than 10%. Okay, the cloud cover should be less than or equal to 10%. So that is what we used here. So you can use cloud coverage assessment, or you could as well use cloud pixel percentage in place of this one, and any of them is going to work okay. All right, so this is how we filter by cloud cover. So this method here is under what? EE filter. If you go to the EE filter, the Earth Engine filter, you will see it here. This is it here, and then less than or equal to, which is the LTE. So you can see that one also here, right? So once you read about it in the description, you'll be able to understand this line of script here, which says that you need to provide a name and a value. The value provided is 10, and the name, see the name, what is name? So the name, if you go here, it says that it should be a string, and that is the name of the property, right? So the name of the property we are looking at here is what? The cloud coverage assessment. So that is the property name. You can see it is what? Under properties. That's the property name we have here, and then the value is what? 10. So once we run this, let's see what we're going to get. So I'm going to run this line of code, and what do we have here? So again, click on the expander, and now we have 71 images. It was over 300 images in the previous run, but now everything has been slimmed down towards 71 images. And let's check the first image to be sure that we don't have pixels with huge amount of cloud cover. So again, when you go to properties, you can see this the cloud cover percentage, the cloud coverage assessment is nearly 0%. So it is essentially free of cloud cover, which is really good. So now you should be happy with the data set you have. So it means that you are going to work with 71 images for your analysis and for the project. Okay. Well, so this is how you take an image collection from Google Earth Engine database, and then you filter it to your project area. So I hope you can do it all by yourself. Keep practicing. Thank you for watching, and please subscribe to the channel for more videos.